Alrighty, today's lesson is area of a plane region. To find the area of a plane region, what we have here, I mean, this is a picture illustrating it. This kind of like the base equation, you know. When it comes to dx, is top minus the bottom. I'll explain in a second. And then if it was dy, it would be like, top would be like kind of like right. So it would be like from right to left. But let's talk about this picture for a second. If you have two graphs, like over here, we have an upside down parabola, and then we have a regular parabola that shifted a little bit upwards. Oops, that was a bit wrong. If you're trying to do that, you're going to be doing integrations. And specifically, you're going to do an integration for both of them, and then you're going to subtract them. And here's why. Let's do the integration for the upside down parabola for a second. I'm going to do that in green. All right. If I do this integration, there's green. If I do this integration, starting from here and ending right there, I'm going to get all of this area. I'm going to get all of that. And then if I do it for the upside down parabola, I'm going to do this in red, I'm going to get all of this. Because the integral is pretty much the area from the graph all the way to the x-axis. That's if you're talking about the x. So to find this region between this one, let me just use a pen real quick. If I'm looking for this region right here, then what I'm going to need to do is I'm going to subtract those two areas, this integral, because this is the overlapping stuff. You see it how much it's highlighted. Like all this stuff I'm about to draw in black. This right here is the overlapping stuff. So when you subtract these two areas, the overlapping stuff is going to go away. So by doing the integral from the top minus the bottom, you pretty much are getting the region that's not overlapping. So that's how you do it. So the process that you would have to do, step number one, is find out where they intersect. So if you want to find out what this point is, you also want to find out what this point is. Step two, do the integral for both. So integral for both. And then step three, subtract. Or step 2 and 3 can be combined by just doing this formula right there. All right, so that's how you do the area of a plane region when it's being created by two things. So let's do the next thing, because there are other situations. Alrighty, so let's say you have a situation like this where it's right at the x-axis. In order to get this bottom graph to become positive, because if you take its derivative, it's going to be negative, just attach a negative, you know, so the negatives cancel, make it positive. Because if you were to do this normally, then these two areas would cancel each other out. So in order to turn this bottom area into a positive, you just attach a negative. Well, here's what I mean. I mean, your integral for this integral is going to be positive because it's above the x-axis. This integral will give you negative because it's underneath the x-axis. But because you're looking for area, it's beneficial for us to make this positive, which is why there's a negative right there. All right, let's move on. All right, let's do this example. Find algebraically by fundamental theorem of calculus the area of the triangular region in quadrant 1 that is bounded by this one, and the y-axis. Let's go ahead and highlight the bounds real quick. So we're supposed to bound it by this graph, and by the y-axis. So the region in question is going to be right here. That's the bound. By those three things, that's the bound. Okay, so we got that out of the way. Remember, it's going to be the integral of the top minus the bottom. The top equation is this one. It's going to be the 4 minus x squared. And the bottom equation is the stuff in green. It's right here. Well, I used red. And that's going to be 4x minus x squared. So go ahead and plug those in. So the top one was 4 minus x squared. Bottom one was 4x minus x squared. And then do some algebra to get it now all nice and cozy. And then We're going to add like terms, and then we're ready for the integral. This is the last thing we're going to do, so this video is going way too fast. Let me just explain why. You might be wondering, hey, how's that possibly the area? Well, if I do the integral of, let me just erase some stuff. Maybe I'm going too fast, because I just went kind of fast. I'm like, what if I'm not explaining this correctly? Because you need to understand. You're learning today. Alrighty, so for the 4 minus x squared, that's this graph. If you take its integral, then you're getting all of this. All of this is what you're getting when you take its integral. And then if you do the other one, this one, in blue, you're going to get all of this area. So the overlapping area that you're trying to get rid of is going to be this guy. So by taking these two integrals and subtracting them, you're going to be left with this area right here, the stuff in green. I hope that makes sense. So pretty much, if I have this, and then I got this, and I subtract the two, I'm going to be left with this, if that makes sense. All right, so let's go back to it. We added like terms to get it all nice and cozy. Then we're going to take its integral, which is going to be this. The process you should understand. The integral is 4x, and then negative 4x will be 2x squared. You can test it by just taking the derivative. The derivative of 4x would give you 4. The derivative of negative 2x would give you negative 4x. And then you just plug in 1 and plug in 0. 0 you don't really need to plug in. You know it's going to go away. So it's going to be 4 minus 2, which is 2. That's the answer. That's the video. We are finished. Have a fantastic day.